Hello everyone. Last video we have discussed about methods of analysis. Those are nodal analysis and mesh analysis by using KVL and KCL methods. Okay. In this we are going to discuss about superposition theorem. And what is the superposition theorem? What are the procedures? We can say steps to find the superposition theorem, how to use this one, what are the steps required for this theorem, and also application for the circuit. Okay, now before going to the in-depth, first we will see the what is the objective of this. So objectives are here. On the completion of this video will be, you would be able to state the superposition theorem, explain the superposition theorem, and also apply the superposition to the different networks, electrical circuits. Okay. Now here we will see what you required here from, that is a known values to unknown values. What is our objective? Previously what we from. So already we know Ohm's law. Ohm's law provides the fundamental tool for solving the electrical networks, but it has some limitations. It won't obey the non-linearity, right? So it cannot be applied to circuit where more than one source is acting simultaneously. Sometimes in the electrical circuits we may get two sources or more than that also. So at that time directly you can't apply this law. Okay. In such cases we have to go for the another laws, those are KCL and KVL. This already we have discussed in the previous videos. Okay, KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Okay, now if a circuit has two or more independent sources, one way to determine the value of specific variable, that is current or voltage, is to use nodal or mesh analysis. That is a previous videos already have discussed those methods, nodal analysis and mesh analysis. If you are having more than one source, you can say two or more independent sources. Another way is to determine the contribution of each independent source to the variable and then add them up. So the second one, it is a later approach, is known as superposition. Okay. The idea of superposition rests on the linearity property. Okay, so later part, if you want, that is a more than two variables, independent sources. At that time, if you want to find the different value, that is a voltage or current. So previously we used to nodal or mesh analysis. So this one we can use to find those variables. That is a superposition principle. Now we'll see so this is, even while applying KCL and KVL to the networks, we have to see how many, that is the number of simultaneous equations to be handled become more, because sometimes if a network is complicated, at that time writing equations and then solving after, suppose if it is 3 or more, then it is very difficult to solve within the specified time. Okay, this leads to error in results. In such cases, we can use this theorem. Compared to those methods, this is an easy method for finding those values. Okay, how it is, now we'll see the statement and then we'll go for the explanation of superposition theorem. Okay, now superposition states that in a network of linear resistances containing more than one source of EMF, The current which flows at any point is the sum of all the currents which would flow at that time, that is at the point, if each source were considered separately and all others were replaced by their internal resistances. Okay, in the same theorem, we can use another alternate statement for this. That is very easily you can understood that both are same only in a simple manner. How it is, just you see here. Or superposition principle or theorem states that the voltage across or current through an element in a linear circuit is algebraic sum of the voltages across that element or currents through that element due to each independent source acting alone. Here the thing is here both our meanings are same, but only thing is in the second definition the statement it gives in a simple manner. The voltage across or current through element in a linear circuit is, if you are taking voltage across that element, for example V. So two sources are there. If you assume V1 one source, V2 one source. If you are taking at a time first one source you should have, second should be inactive. At that time what is the voltage? So you will get some voltage. Second time when you are applying another source, at that time what is the voltage? When you are applying both, so that is only here. So that value is equivalent to some of the individual values if you are taking either voltage or current. Okay, that is a superposition principle. Okay, now we'll see here steps to apply superposition principle. Okay, turn off all independent sources except one source, because this theorem we are applying for the if sources are having more than one, two or more, right? So turn off all the independent sources except one at a time it should have. That is the meaning of this. Find the output. Here that output it may be current or voltage due to that active source using the techniques. Okay, so those techniques depending upon that you can use either mesh analysis or nodal analysis depending upon that, or if it is simple one you can go for the Ohm's law also. Okay. Repeat the step 1, same step. Okay, this one same you can repeat for each of other independent sources. Suppose you have two sources, first time you take first one and then second time you take another. That is the same steps you have to. At that time also first one it should stop and second one only it should act. Okay. At that time again find the output, that is the voltage or current. Find the total contribution. So total value how to find by adding algebraically all the contributions to the independent sources. Already you are taking here one source, here another source if you are taking two, right? So at this time what is the value? Either voltage or current. Here what is the value? For example, if you are taking here voltage V1, right? If you are taking same voltage, that is a whatever value you are getting V2. Summation of these two when you are applying both the sources. Okay, so that is meaning of this. Find the total contribution by adding algebraically all the contributions due to the independent sources. Okay, these are the steps required to apply the superposition principle to the circuits. Okay, now, so here what we are doing when you are applying the superposition principle for the circuits, internal resistance of an ideal voltage source is 0. You need to keep in mind. So, internal resistance of ideal voltage source, if it is ideal, the internal resistance is 0. Okay, that is nothing but short can be at that time. Internal resistance of ideal current source is infinity. Okay, so at that time, if it is there, we can put that source. It is a open circuit. That is the main. You need to keep in mind this one. If ideal voltage source is there, at that time we have to go for the short circuit. If it is a current source, at that time we have to go for the which one? Infinity, that means open circuit. If the given sources are non-ideal, replace with their own resistances. Okay, whatever the value they have internal, we can keep same value of that resistance. Okay, that is. Now we'll take one example here. So this is circuit. We have two sources here. One is a voltage source, another one is current source. It's a simple source. Now we will see how we are applying this superposition principle to this circuit. Using superposition principle or theorem to find the voltage in the circuit of figure. This is the question. Figure 1 it is mentioned. It's a very simple. Okay. How what are we have to take at a time we have to take, because we have two sources here. At a time we have to take only one source. Find the value, because V is given voltage across the resistors, that is a 4 ohms resistor, right? So you have to find that value in both the cases, and both sources, if you are acting at that time, what is the source you have to find. You have to check both. That is very important. Now we will see here first case. Okay, so already we have two sources. Let when we are taking sources, first one, when you are acting at a time first source, you take this voltage is V1. You take that. When you are taking the second source, that is a current source, 3 amperes. So at that time, that voltage is which one? V2. Okay, because we have two sources here, so we need to find the total voltage is equal to V1 plus V2. Okay, in this problem. Now, first case, we are taking here only voltage source. 6 volts only is acting, so current source it is not acting, so that means what you have to take, it should be open circuit. It is open circuit here. This is open circuit. Okay, so now here you have to find the value of this V1. Okay, how you will find out here? Just you see here, to obtain this one, to obtain the value of V1. So what you have to take, this one it should be 0, that is nothing but open circuit. Okay, now when it is 0, now you can see the expression. You have to apply for the KVL, because it is one simple loop here. It is only one simple loop. You know how to write the expression here. Directly you can take here 6 equal to 8I1, because both are in series, right? 8 plus 4I1. So that is a 12I1 is equal to 6 directly here, or 12I1 minus 6 equal to 0. Both are same. Either you take 6 equal to, so 8I1 plus 4I1, because there is no another current here, because second one it is 0, right? So I2, that is also I1. Now when both are same, that is a 8 plus 4, 12 I1 is equal to 6. So what is I1? This is the value. I1 is 0.5. So this current, because of series, same current flows in this also. So what is the voltage across this resistor? V1 is equal to 4 into I1. What is I1? 0.5. So V1 is equal to this. I will say 4I1. 4 into 0.5. 4 by 2 means 2 volts. This is the first case. Right? This is a one way. In the same, we can use another method also to find this. You got here, right? 2 volts. Now we will see another way for this to find the value of this. You can use here which one? You can go for the voltage divider rule also you can find here. Just to see, this is the total voltage here in this case. So how much voltage across this? Across this. We want only this one. We want this means V1 is equal to total voltage 6, that is a 6 volts, into opposite resistance. Actually it is, that is only here. When it is going for the current, you have to go for the opposite. When you are going for that particular, so 4 into current, right? 4 into I1. What is I1 here? So 6 by 8 plus 4, that is only here. 4 into 6 by 8 plus 4, right? How much you will get? 24 by 12. You will get same. This is another method. By using voltage division also you can say either this way or this way. That is up to you. You can use for finding this, either that method or this method. Next, we'll see another source when it is acting at that time, how much value here. Again, you have to find the voltage across the 4 ohms resistor only. Now we'll see second case. Okay, this is second case. Here, what is happening? Just you see here, to get or to find the value of V2, because now current source is acting. Current source is acting. Voltage source is okay. Shall find V2, that is a voltage across 4 ohms resistor. So here we are using only one source, that is a current source. Current source, this is the source. So at that time, here actually it was a voltage source. But when it is acting single source, this voltage source, it should be short circuit, right? Previous one, that is a, or if it is a current source, it is an open circuit, but this one it is a short circuit. Okay, that is you need to understand why you are keeping short circuit and why you are keeping open circuit, where you have to keep this one. Okay, then now only one source it is there, current source. So when you are going for the current source, you have to find the value of voltage, that is a V2 across the 4 ohms resistor. Directly here, if you are assuming this is I2, this is I3, this I3 only you want. How to find out? Total current is 3. Again here you can go for the current division. You can take here this current division, that is I3 is equal to total current into opposite resistance value by total value. Now you see here, so 3 amps, 3 into 8 by 8 plus 4. Directly you can see here, this is, that is a current division principle. Okay, so 8 into 3 by, again here 12, right? Again 2 amps. This is current. Now what is V2? 4 into I3. Let's substitute this value. 4 into 2, 8 volts. So what is the value? Total value, if you are applying both the sources, this voltage is V1 plus, that is first case it is 2 volts, second case it is 8 volts, total 10 volts. Now you see here, that is, in this way you have to apply for the superposition for the circuit. Okay, now we'll take another example here. Okay, this is the circuit. Now you can see, so here also two sources, two are DC sources only, both are voltages. Previous case I have taken one source current, one is voltage, but here two are voltage sources. Here again you have to find the value, so that you will see the, see, consider the network shown in figure. Okay, two sources already we have, we can observe that one, and how we are applying, that is only thing here you will see. By using superposition theorem to the circuit, so first case it is, so what is happening here, second source it is inactive because of voltage, it is short circuited, because of, that is the source, it is a voltage, that's the reason it is short circuit. Then you have to find the value. So here you see here, first consider V1 only is acting alone. So this is the circuit diagram for that. Then therefore other battery already it is we kept here. This is the short circuited this one. Now we will see when we will remove, you can find out the resistance value first. How it is, you can see. Okay, because now you see when it is there, what is the resistance value here? Because total value how to find out this voltage by total resistance. So that is nothing but current, right? So how you are finding here? This is the 28 volts that is supply here, but equivalent resistance of this is 4 plus these two are in parallel, right? So these two are in parallel. So how to find out this? These two only equivalent value of this 2 into 1 by 2 by 1. So that is this one. You see here 2 into 1 by 2 plus 1. So this one plus in series with this 4 plus 2 into 1 by 2 by 1. That is the resistance of this circuit. If you know the resistance and voltage, already we know the Ohm's law. Directly from that we can find out V equal to IR, I equal to V by R. This is only here V by R, because already we found R here. V already it is given. V is 28 and I is this one. So this value is this. Clearly it is okay. That is the value 6 amperes because unit is amperes. In the second case we will see here how it is, because at that time you have to take only another source, not V1, it should be V2. Okay, now we will see that one. This is also same. You can observe directions of currents also. Already we found how much it is. Okay, in this case, here we got this currents we got. So in this case, total current it is given 6. So when it is 6, so how much flowing in this and how much current it is flowing in this. That we can find out by using independent. Okay, we can find out that. Now we'll see currents through various parallel paths can be easily obtained by using current division principles. Already in the previous problem also we have taken current division principles. So I can find out total value. If it is a total current is there, this is the total current, right? This is the total current. So based on the resistance values, we can find where it is, how much. So if you want to find out this current, you have to take this total current into so opposite value of this resistance by so total resistance this plus this. You can get that. Okay, in this if you want to find out this one at the time total current into this resistance by this plus this resistance, in that way you can find out. Okay, that is now we'll take this one, that is a voltage acting across also you can find out if you want, but here our motto is just apply this one both the sources individually and find out those currents. Now we'll see second case. In this case again only one source is acting, that is a V2. Okay, that is V2 is acting. I will see. So when it is V1 should be short circuited. Now you see this is the V2 source only it is acting. This is the source V2, right? Now this is the which one? V1 source, actually it is a voltage source. So when it is acting second source at that time it should be short circuited. It should be short circuit. Here S means short circuit. In short form I am writing here SCR S by C, short circuit. Okay. Now again same principle how to use here. So find the equivalent of this resistance. So voltage by resistance, again find out the current. Now you see here, you can take this plus these two are in parallel. Okay, what you will get here? 1 plus 4 into 2 by 4 plus 2, right? 4 plus 2, because both are in parallel. What you will get? 1 plus 8 by 6. Okay, now you'll see that how it is. You see here, same thing. So 1 plus 4 into 2 by 6. You will get the value of resistance, that is this, when only second source is active. Now you have to find the current. How to find it? Again you have to use Ohm's law, right? What is Ohm's law here? Okay, V equal to IR. That only you have to use here. So nothing is required. It is a very simple law. Directly you go for that V equal to IR. Okay. So when you are taking this one V equal to IR, directly you want to find this current here. So what is the current here? V by R. Right? So V how much? 7. V is given 7. Okay, that is 7, and resistance value is this. Just I am putting here 7 by 2.33. How much you will get? Just you will see here. Already I have calculated. That is 3 amperes. Okay. In this way you have to find. So now two sources individually you have taken. Now how much total? Just add both. One case it is 3. Another case it is, how much you got here? 4. Sorry. How much you got here? These two. Right? In both the cases. Again here also you can go for the current division principle. You can find the current individually, and if you want to find the voltages across the individual, so you can go for the voltage division principle. Both you can find out here. Okay, both you can find out. Once you are finding the current, voltage across current is nothing but I into R. How much resistance it is multiplied by the current. Okay, in a simple manner you can find. If you want to find the current, at the time compulsory you have to use current division principle. Okay. For example, if you want to find the current, already we know the total current here, we got 3, right? So this is the total current. If you want to find out this current, so total current into opposite resistance by total resistance. In this way you have to find out. Okay. So that is a general principle if you are taking. It is general principle. Now we will see, if you are taking both the sources at a time, that is this. You see here, when you are taking two sources at a time, this is first source, this second source. For your understanding here, we have taken both currents as well as voltages. Generally, they may ask only single. You find out one particular branch. Okay, so apply this principle, find out the voltage, or they may ask find the current. But here in this example we have taken both voltage and currents. So easily whatever they ask in the examination, in simple manner we can find the voltage or current. Okay. Now you see here, this is two sources are acting at the time. If you want to find out only voltages, you see here this is the 6 or 7 volts in the second case, right? How much you will get here? This value is 8 into 8 volts, right? So how you will get this current? Already we got. How much we got here in this case? That is only this 4 into resistance value. Okay. Or if you are taking, already we got here 4 into. Okay. So if you are taking here, this is a 1 into 1 volts. Here 20. Now you see, just you take this one, 28 is equal to 20 plus 8 at a time if you are taking. If you are taking at a time this one, 7 is equal to 8 minus 1. This is only polarities here. When it is current, you have to take the directions. When it is a voltage, you have to see the polarities. That is very important here. Okay, you need to understand where you have to take only polarities, where you have to take directions. Otherwise, if you are taking this direction, if you are taking that is a positive, opposite if it is, it should be negative. Suppose this one, it is compulsory minus 5 amperes. Okay, that is. In this way, you have to find the voltage or currents across the particular branch. Here, our main thing is either any branch you can find. That is not like only this branch. Here also you can find, here also you can find out wherever we want. Based on the problem we have to find. That's the reason we have to take this example. If you understood this problem, any problem you can solve easily. Okay, this you see here, figure 6 shows the voltage acting across various elements. Figure 7, those are the currents here. Please note, while superimposing, that means at a time if you are applying both the sources, at that time you have to consider direction for the currents, right? If currents due to all sources are acting in same direction, simple add. If they are opposite, just subtract. That is only here. Minus you will get, right? That is a subtract is nothing but minus of addition only. Same rule applies to the voltage acting across the resistor. There you have to see only, it is not like directions. There you have to go for the polarities. So, analyzing a circuit using superposition has one major disadvantage. We have many advantages, but one disadvantage is also having this superposition principle. Now, it may very likely to involve more work, because if you want to find one circuit that is solving that one, you have to take first time single source you have to apply, second time another single source you have to apply, and then apply both source, right? Then only can get, because work it should be time consuming also. You can say more work involves here. If the circuit has three independent sources, if sources are increasing, that is a mean. You may have three simpler circuit, each providing the contribution due to the respective individual sources. Okay, so if you have 3 or 4, that is a, if network is, that is a complex, here also it is time consuming. However, superposition does help reduce complex circuit to simple circuit. That is another, that is the main advantage here, because it is simplifying and then finding the values. That is another advantage of this. The replacement of voltage source by short circuit and of current sources by voltage, that is a open sources. That is called open circuit. Okay. So in this video we have discussed statement of superposition and steps for the superposition, how to apply for the circuit, and then apply of superposition to the electrical circuits. Okay, these three things we have taken with examples. Thank you for listening.